For decades, Toyota built its reputation on quiet strength, the dependable force behind millions of drivers worldwide, never needing to shout to be heard. But something shifted. In a rare, pointed statement, Toyota's CEO stepped into the spotlight with a message few expected: "Our new dynamic force engine will destroy the competition." It was more than a challenge. It was a signal that Toyota was no longer content staying in the background. So what exactly is this engine, and why is Toyota so confident it will leave everyone else behind? Let's uncover the real story behind Toyota's boldest move yet. Toyota is not just improving its engines, it is changing how they work to meet future needs. With its new Dynamic Force engine series, Toyota is focusing on improving fuel engines, while many other companies are switching completely to electric vehicles. These engines are not small updates, they are part of a long-term plan connected to Toyota's global design system called TNGA, or Toyota New Global Architecture. This system helps Toyota build cars that are stronger, more efficient, and easier to produce. While many companies are focusing only on electric cars, Toyota is improving both fuel and electric systems. The CEO of Toyota said that the new Dynamic Force engines are a big part of the company's plan. These engines are designed to use less fuel, create fewer emissions, and still deliver strong performance. They can also work with different types of fuel, such as ethanol or hydrogen. Toyota believes that fuel engines can still improve and play an important role in the future of transportation. This choice is based on global needs. In many countries, electric cars are not practical because charging stations are limited and electricity is not always reliable. In those places, efficient fuel engines are still the best option. Toyota is building engines that can work in these areas while also meeting environmental rules and keeping costs low. The new Dynamic Force engines are designed to work with Toyota's TNGA platform. TNGA is a system that allows different cars to share the same parts and design. This helps reduce production time and makes it easier to use the same engine in many types of vehicles. For example, the same engine could be used in both a small sedan and a larger SUV without needing a full redesign. This system helps engineers focus on making engines better instead of starting from scratch each time. It also allows Toyota to bring updates and improvements to many models more quickly. This approach saves money, reduces waste, and supports future changes, like switching to new types of fuel. The Dynamic Force engines focus on more than just speed or power. They are built to be efficient, reliable, and better for the environment. One of the most important changes is their high thermal efficiency. This means the engine can turn more fuel into usable energy rather than losing it as heat. These engines also use a longer piston stroke and a mix of fuel injection methods to improve performance and reduce emissions. Cooling systems are also more advanced. Electric water pumps and better temperature control help the engine stay at the right temperature. This makes the engine last longer and work better in different weather conditions. Every part of the engine was designed with care to support both performance and fuel savings. The Dynamic Force series includes 3 types of engines: a 3-cylinder, a 4-cylinder, and a V6. The i3 is small and uses less fuel, which is good for compact cars. The i4 is the most common type, found in many mid-size cars. The V6 is stronger and made for larger vehicles that need more power. Each engine can work with several types of fuel. Toyota is testing options like ethanol and hydrogen. These engines are also designed to work with hybrid systems, so they can be used in both fuel-only and hybrid cars. This gives Toyota many options when building new vehicles. Toyota builds these engines using its global factories. The design allows for flexible production, so the same engine can be made in different countries with local parts. This saves time and money while keeping quality high. Because these engines follow the TNGA system, Toyota can quickly adjust production based on local needs. For example, if one market needs more ethanol-based engines, Toyota can shift resources without major changes. This kind of flexibility is useful in today's fast-changing industry. The Dynamic Force engines give Toyota an advantage. While other companies are moving away from fuel engines, Toyota is improving them to meet both current and future needs. These engines are ready for multiple types of energy and work well with hybrid systems. This makes them useful in many markets, especially in places where electric vehicles are still not practical. The new engine design, along with the TNGA system, helps Toyota keep costs low and quality high. This means customers get cars that are efficient, dependable, and ready for future updates, all without giving up performance. By using TNGA, Toyota can produce many vehicles with fewer changes in the production line. It also makes it easier to add new engines like the Dynamic Force series across many models without changing the entire car. This speeds up development and lowers costs while still allowing each car to have a unique style and function. One of the main goals of TNGA is to support new technology. That includes not only better safety and comfort features but also new types of engines. The dynamic force engines are designed to fit perfectly within the TNGA layout. This means engineers don't have to redesign the car every time they improve the engine. This helps Toyota stay ahead in markets where clean energy is growing quickly. By building flexible cars that support different powertrains, Toyota can adjust its lineup without big design changes. This is a major advantage in today's auto industry, where energy systems are changing fast. Several cars built with TNGA and dynamic force engines are already on the road. Models like the Toyota Corolla, Camry, and RAV4 use this setup, and they have seen improvements in both performance and efficiency. Drivers notice better fuel economy, quicker response, and smoother driving. For Toyota, these results show that the TNGA system works as planned. It supports fast changes, reduces production time, and helps introduce new engine technologies across many models. This gives the company a strong position in both traditional and emerging markets. Every major leap in automotive progress begins at the engine. For Toyota, the dynamic force engine represents the next stage in internal combustion design. These engines are not simply a tweak of the past, they are a complete redesign of how power, efficiency, and emissions are balanced. Developed from scratch and built to pair with Toyota's TNGA platform, the dynamic force family brings a focus on thermal efficiency, smart air-fuel management, high-speed combustion, and mechanical precision. Toyota's engineers set out to achieve what most considered extremely difficult, increasing thermal efficiency in a gasoline engine to levels typically seen only in hybrid or diesel powertrains. In internal combustion engines, thermal efficiency refers to how much of the fuel's energy is converted into useful work. Traditional gasoline engines tend to have thermal efficiency in the range of 30 to 33%. The dynamic force engines break past that limit, with figures reaching 40% in gasoline-only configurations and even 41% in hybrid setups. This improvement comes from a combination of technologies working together. Instead of focusing only on one system, Toyota looked at how each part of the combustion process could be enhanced. That includes how fuel is delivered, how air flows into the cylinder, how the combustion chamber is shaped, and how heat is managed during ignition. Improving all of these areas led to the record-setting efficiency numbers Toyota now claims. In regions like South America and parts of Asia where ethanol blends are already common, Toyota is advancing ethanol-compatible versions of these engines as part of its localized strategy. This flexibility makes dynamic force engines future-proof for regions with unique fuel policies, allowing Toyota to participate in multiple transition paths to carbon neutrality. Additionally, Toyota is collaborating with energy companies in Japan and Germany on testing synthetic fuels made from renewable hydrogen and carbon captured from industrial processes. These tests will determine how dynamic force engines perform with drop-in e-fuels and whether existing combustion hardware can be used with minimal adaptation. Early results are promising. With the right combustion tuning, these fuels offer emissions reductions without significant hardware compromise. One of the most groundbreaking directions for the dynamic force architecture lies in hydrogen combustion. Unlike hydrogen fuel cells, which convert hydrogen into electricity via chemical reactions, hydrogen combustion engines operate similarly to gasoline engines, but burn hydrogen instead. Toyota has already demonstrated hydrogen combustion technology in vehicles like the modified Corolla Sport and GR Yaris. These engines are based on the dynamic force family, adapted with reinforced injectors, upgraded spark plugs, and flame control systems to handle hydrogen's unique combustion characteristics. While still in the early stages, hydrogen combustion represents a bold alternative to both EVs and fuel cells. It enables fast refueling, high performance, and a familiar powertrain layout while producing near-zero carbon dioxide emissions and only trace amounts of nitrogen oxides due to high-temperature operation. This makes it particularly attractive for motorsports, commercial fleets, and regions with green hydrogen infrastructure. Toyota's vision is to use dynamic force-derived hydrogen engines for niches where battery electric vehicles may fall short, such as long-distance driving, heavy-duty use, or cold climates. If scalability challenges can be resolved, these engines could become a pillar of Toyota's diversified zero-emissions roadmap. Toyota has committed to carbon neutrality by 2050, and dynamic force engines play a strategic role in that vision, especially over the next 15-20 years. Unlike some rivals who aim to phase out ICE by 2030, Toyota believes a multi-path strategy is more practical and inclusive for emerging markets. In the company's roadmap, dynamic force engines will gradually shift toward exclusive use in electrified powertrains, including hybrids and plug-in hybrids. Pure ICE variants will slowly phase out as electrification expands. By the early 2030s, most Toyota vehicles are expected to use dynamic force technology in some hybridized form, delivering low emissions and reduced fuel consumption at scale. Simultaneously, Toyota will continue investing in solid-state batteries, full EVs, and hydrogen fuel cells. But unlike competitors who are betting the house on one solution, Toyota is hedging its bets, allowing its dynamic force architecture to act as a reliable backbone for markets that are not yet EV-ready. This hedging isn't indecision, it's strategic flexibility. The global transition to zero emissions will not be uniform, and Toyota's strategy ensures that it has a scalable, efficient, and proven ICE hybrid option ready to meet customers wherever they are on the path to electrification. Toyota's bold claim must also contend with a different kind of competition: manufacturers who've completely abandoned combustion engines. Tesla, BYD, and other EV-only players are redefining what powertrain innovation means by removing ICE from the equation entirely. Tesla, for instance, has pushed the industry toward ultra-efficient electric drivetrains with permanent magnet motors, silicon carbide inverters, and high-voltage battery packs. BYD has taken a more integrated approach with its e-Platform 3.0, combining blade batteries, compact motors, and advanced power electronics into a tightly optimized package. In markets like China and Norway, EVs already outsell combustion vehicles. In these environments, Toyota's dynamic force engine isn't a threat, it's irrelevant. However, the world isn't homogeneous. In Africa, Southeast Asia, Latin America, and parts of the US, infrastructure and cost barriers remain. In these regions, Toyota's hybrid and ICE offerings continue to outsell EVs by a wide margin. Toyota's argument is simple: until EVs are cheap enough, clean enough, and fast enough to charge anywhere in the world, dynamic force engines, especially in hybrid form, offer a more realistic, scalable solution. And for now, the sales data agrees. While many competitors can match Toyota in innovation, few can rival its production scale, vertical integration, and reliability history. Toyota builds millions of dynamic force engines annually, supported by a supply chain optimized for everything from raw casting to final assembly. Toyota's dynamic force engine isn't just a technical upgrade, it's a statement. A reminder that the internal combustion engine still has fight left in it, and Toyota isn't ready to give up its crown without a battle. As rivals rush toward full electrification, Toyota is quietly building something far more strategic, far more calculated. But in a rapidly changing auto industry, will this bold engine be remembered as a masterstroke or a missed opportunity? Let us know your thoughts below. Don't forget to like and subscribe.